All right, so in this video, I'm going to go through and solve this quadratic inequality, but this time I'm going to use our alternative method, our second method, which is testing values instead of sketching and shading. So let's walk through how I would solve this to start off. We said that in order to solve a quadratic inequality, we pretend it's an equal sign and solve as we normally would by either factoring, square rooting, or quadratic formula. Looking at this, I see parentheses squared, and then everything else is a number, so solving by square rooting would be the most efficient. So I'm going to move the 18 over, so keep the 2, keep the parentheses squared, move the 18 over and switch this to an equal sign because we're just solving for the x values. Okay. Next up, I would divide out the 2 to get the parentheses squared alone, and that gives me a 9 on the right hand side. And then from there, I can square root both sides. So if I square root the left, that'll make the parentheses squared go away and give me just the x minus 1. And then I'm going to square root the right as well. I'm square rooting a number, so I need the plus or minus involved, okay? Square root of 9 is 3, so this is positive and negative 3. And now because it's all integers, I can split it into my two cases, where I have x minus 1 is equal to positive 3, and x minus 1 is equal to negative 3. Add the 1 over to get x equals 4. Add the 1 over to get x equals negative 2. So those are the two numbers that are going to go on our number line to set it up for our test values. Okay, so this was our method 2. Method 2 was to test values. So what we do is we make a number line and we mark our two x-intercepts. Remember, we need to put them in order, so negative 2 comes first, 4 comes second, because we have to go from least to greatest on a number line. Now there is an equal to in this inequality symbol, so that means I can equal these, so I draw closed circles either above them or right on the number line if you prefer. All right. And we talked about how because this is related to a parabola, parabolas have the shading either inside or on the two outsides. So either a number in the middle will work or the numbers on the outside will work. But it can't be in the middle and on the right or in the middle and on the left. So the easiest way to do this is pick a number in the middle and see if it works in the inequality. Okay? So I'm going to try x equals 0, something in between negative 2 and 4. So I'm going to test x equals 0 and see what happens. All right? So that means looking at the original inequality, 2 times x minus 1 squared minus 18 greater than or equal to 0. That's the original problem. Replace the x with a 0. And then just simplify that left-hand side to see if you get something that makes a true statement or a false statement. Remember to follow your order of operations. So this is 2 times negative 1 squared minus 18 is greater than or equal to 0. Negative 1 squared is positive 1, so this is really 2 times 1 minus 18 is greater than or equal to 0. So I've got 2 minus 18 greater than or equal to 0. Well, that's negative 16. Is negative 16 bigger than or equal to 0? And that's a big fat no. This is a false statement. That means x equals 0 is not a solution to this inequality. So that means none of the values in the middle where x equals 0 lies, none of them are going to work. Since nothing works in the middle, we are officially guaranteed that the numbers outside will work. I don't have to test them. You can if you want to, but if you plug in something like 5 or negative 4, they're both going to work. So that means I can take this and extend arrows off to the two sides on this particular one. All right? What we need to do now is we need to go through and write our intervals that match that number line. Okay, so I'm going to give myself a little bit more space over here to try to write out the intervals. Okay. And remember, interval notation is something that looks like coordinate points, but sometimes you have those square brackets instead of the round parentheses, okay? So I'm just going to redraw my number line here for a frame of reference. I've got from -2 and 4 closed circles and the outsides. Okay? So this is going to the left forever to negative infinity, and it ends right here when I get to -2. So I'm going from negative infinity to -2. All right? Parenthesis means I cannot equal the number. Bracket, the square bracket, means you can equal it. You can never equal an infinity, so that's a parenthesis. Here it said equal to, so I can equal this. That's what the closed circle means, so I have a square bracket there. And because I have two separate pieces, I have two separate intervals, so I need a union sign. The next interval starts here at 4 and continues right to positive infinity. So I start at 4 and go to infinity. I go forever. I can never equal an infinity. That's always a parenthesis. And then I can equal this 4 because it was a closed circle because of the equal to. So I have a square bracket. So that's the interval notation answer. And then I also want to be able to write this as an inequality. If I look at the -2, I'm going to the left of -2. Left means smaller than, or equal to in this case. Two separate pieces means I have an or in between. And then this second one with the 4, I'm going to the right of 4, so bigger than 4, so x is greater than or equal to 4. And that's my inequality solution. Okay? So there's example B done out with the second method.